We saw that the function y equals x squared is not a one-to-one function. This means that y equals x squared does not have an inverse function. Or does it? We've been using the square root function to undo x squared. Is it not its inverse function? To address this, let's take a closer look at our idea of one-to-one functions. F is not a one-to-one function if we look at the entire domain, from negative infinity off to infinity. But if we restrict the domain to only values of x bigger than or equal to 0, in other words, the right-hand side of our graph, then f is one-to-one. Restricting the domain means we only input values of x bigger than or equal to 0. This creates a new function, we'll call it f tilde, that equals f for values of x bigger than or equal to 0. The only difference between the two functions is what we're using for inputs, what our domain is. The domain of f tilde is everything from 0 to infinity, while the domain of our original function was all real numbers. So on this domain, where x is bigger than or equal to 0, f tilde is one-to-one, so we can find an inverse of it. And we found it before. The inverse is the square root of x. So restricting the domain of f of x equals x squared to x is bigger than or equal to 0 gives the one-to-one function f tilde of x. And f tilde has an inverse, the square root of x. Now, let's make some observations about this. We can get the graph of f tilde inverse of x equal to the square root of x by reflecting the graph of f tilde across the line y equals x. This agrees with the graph of the square root of x that we found earlier. In addition, the domain of our function is the range of its inverse, which is everything from 0 to infinity. And the range of f tilde is the domain of its inverse, which again is everything from 0 to infinity. This is why when we take the square root of a number, we only take the positive one.